At Arizona State University, we've made online education better, smarter, and more personalized so you can go further in your aspiring field.
I decided to pursue medicine once I realized that ASU did have the online program for biological sciences. You're still required to learn the same curriculum. You're still being tested on the same content that anyone would be tested on in person. The comprehensiveness of the program prepared me so well for medical school.
Explore over 300 programs at asuonline.asu.edu. With so many options, why choose Arizona State University?
For me, the only online option was ASU because of the quality. Their faculty was really involved with their students and care about your personal journey. The dedication to my personal development from my professors, that's been extremely valuable to me.
Earn your degree from the nation's most innovative university. Online. That's a degree better. Explore more than 300 undergraduate, graduate, and certificate programs at asuonline.asu.edu.
This is SpaceTime, Series 28, Episode 72, for broadcast on the 16th of June 2025. Coming up on SpaceTime, a new window into the Moon's hidden mantle, unusual stellar nurseries discovered near the centre of the Milky Way galaxy, and another lunar lander crashes onto the Moon. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study of strange green glass beads brought back from the Moon appear to be evidence of what was a massive asteroid impact onto the lunar surface. The findings, reported in the journal Science Advances, are providing fresh insights into the Moon's history and a better understanding of what lies beneath its cratered surface. The beads are just part of the treasure trove of material which has been brought back to Earth by China's Chang'e 5 sample return mission. One of the study's authors, Alexander Nimchin from Curtin University, says that typically lunar glass beads are formed from impacts that melt surface rocks. However, the beads in this study were found to have unusually high levels of magnesium, and that is evidence of a potentially far deeper origin. Nimchin says these high magnesium glass beads may have been formed when an asteroid smashed into rocks that originated from the Moon's mantle deep below the lunar crust. And that's highly significant because scientists have never directly sampled the lunar mantle before. So, these glass beads are actually providing astronomers with a glimpse of the Moon's hidden interior. The thing is, the chemistry of these beads is quite unlike that of lunar surface rocks which have been previously sampled. Just such an event may well have been the origin of the huge Imbrium Basin impact crater, which was formed over 3 billion years ago. Remote sensing has already shown that the area around the basin's edge contains the kind of materials that match the glass bead chemistry, and that's a big step towards understanding how the Moon evolved internally. If these samples really are a piece of the lunar mantle, it tells scientists that lunar impacts can excavate otherwise inaccessible mantle material right up to the surface. And the discovery could have even wider implications by influencing future missions to the Moon and other planets. See, understanding how the Moon's interior is made up helps scientists compare it to the Earth and other planets.
There are some small glass beads in all lunar soils, including Chang'e 5. They've been subject of research for many years. Most of them reflect local rocks, pretty much, that melt during impact, and then this melt is splashed, and then these droplets settle in the soil, and then so the chemistry and then other characteristics pretty much reflect surrounding rocks. They can come mostly from surrounding areas, but some can travel quite a large distance, hundreds of kilometers. And that's what unusual about these glasses we investigated is their very high magnesium content. This content is, as I said, chemistry characterizes rocks that are present on the surface during impact. This high magnesium content, therefore, reflects one type of these rocks, and it's very unusual. It's extremely high, and this type of rocks are not really present in the current collection of lunar samples. The rocks themselves are unusual, and then there are a number of possibilities, but one of them is that they represent parts of lunar mantle that have been uplifted, brought closer to the surface, but by one of these large basin-forming impacts on the moon.
We don't know much about the lunar mantle.
Yeah, most of it comes from geophysics. As I said, these rocks are unusual, even though we always expect to find the samples representing lunar mantle simply because, yes, this large basin-forming impact, thousands of kilometers or close to thousands of kilometers across. They should penetrate through lunar crust into lunar mantle, and the expectation is that they will bring this mantle material to the surface, but it was never confirmed by actual physical samples in our collections. So this may be the first glimpse into this material and the possibility that it was actually brought to the surface at some point.
Where on the moon did Chang 5 undertake its research?
It's on the western side of all previous landings. So it's further to the west from Apollo landings, but it's reasonably equatorial because it's easier to land. They call it prosolarum crit terrain. This is front part of the moon. You can see from whatever if we look in the sky. To the left side of the moon when we look at them from Earth, so to speak.
Is this an area of dark mare or light?
It is. Yeah. It is dark mare because, again, it's easier to land because it usually provides more of the flat surface. So many of missions land into mare. And yes, this was the first attempt to return samples from Chinese space agency. So they landed there. But again, this is mare that was predicted to be young, and it was confirmed by the samples of fossils that they brought. It's about 2 billion years old, which is much younger than everything else. So it's mare, but it's different from all previous samples of mare we've collected.
So if the mare itself is around 2 billion years old,
yeah,
were you able to date the samples, these green glass beads, were you able to date them at all?
Well, yeah, we've dated them. Well, this particular one is very young. It's about 60, 70 million years old.
So this is from an impact that occurred much later than the one which caused the mare in the first place.
Yeah, of course. The idea here is that if we're correct, let's put it that way. And this is the mantle material that was uplifted. It was uplifted somewhere else, probably about 150 kilometers from landing site. And then very young impact, about 60 or 70 million years, hit that, melted it, and then brought these little glasses into the soil that was collected.
Current hypothesis is that the impact may have been the one that caused the Imbrium basin to form.
Well, the original uplift, yes, we think that it's most likely scenario that Imbrium pretty much uplifted these pieces of the mantle, so they and Imbrium was 3.9 billion years ago, and then these pieces are sitting close to the surface ever since. And later impact, if they hit this material, they can generate this remelted and distribute it further in the field in different places, and then we kind of were lucky to pick up one of a few of those small bits in Chang 5 soil.
One of the big mysteries about the moon is the dichotomy of its two sides, the near side of the moon, which always faces the Earth, and the far side. If this is part of the mantle, does this go some way to helping scientists in their search to try and work out why this dichotomy exists? Probably
eventually with some extra information. On its own, probably not. We're just collecting bits and pieces of information, and then when combined, it can help answer some bigger questions, I suppose. Chang 6 aims to address this issue of dichotomy. So we will see in the next few years. It will be discussed quite extensively based on various samples, including Chang 6.
This is another piece to the puzzle, but we don't see the full picture yet.
No, it's usually, again, we analyze tiny bits and then we're trying to make big conclusions about the whole history of the planet or planetary body. It's like going outside, collecting a few grains of sand and then trying to say something about global evolution of Earth. So it has to be taken in combination with all other bits of information we've got, and also new bits of information that will come. Everybody is now interested in exploring moon, so we will get more and more data. And yes, this would add, hopefully, at some point, to finding answers to some of these big questions, including why moon is different on the side we see and the backside.
How do you feel when you get to hold a piece of the moon? That must be amazing.
Yes, first time it is, but then it's kind of become part of your everyday life. And then you stop thinking about it. But yeah, if you think about it, it is. the ability to work with some of the samples. It's really amazing.
I remember the first time I held a dinosaur fossil that was more than 66 million years old. That made me feel that was like a wow moment for me. And I can imagine when you're holding something that's billions of years old, that must just be incredible.
Yes, it's difficult to comprehend, I suppose. Even million years, it sounds like a very long time, but yeah, when we're talking about billions.
Are you looking forward to the sample return mission to Mars?
Yes, of course, we're waiting for that.
2031, I believe.
Yeah, well, the timeline's changing, but it's normal and understandable. There are some, obviously, complications with all of that. But also there is Japanese mission, actually, to Phobos, which is happening quite soon, I think. Couple of years, and then that's another exciting thing that we'll probably like to see.
That's Professor Alexander Nemchin from Curtin University's School of Earth and Planetary Sciences. And this is Space Time. Still to come, the discovery of unusual stellar nurseries right near the Milky Way's galactic centre, and another lunar lander crashes while attempting to land on the moon. All that and more still to come on Space Time. This episode of SpaceTime is brought to you by NordVPN, SpaceTime's official VPN service. Let's face it, these days your online privacy is more important than ever. Whether you're streaming science documentaries, reading the latest research, or exploring deep space images, you don't want your data to be tracked or your location exposed. With NordVPN, one click is all it takes to secure your internet connection. It encrypts your data, hides your IP address, and keeps your activities safe from prying eyes, whether you're at home, work, or connected to a public Wi-Fi. And here's where it gets really good. As a SpaceTime listener, we have an exclusive offer for you. 74% off a NordVPN plan plus 4 extra months for free. That's right, a huge 74% discount plus 4 bonus months just for being a SpaceTime listener. All you need to do is head over to nordvpn.com/StuartGary. That's nordvpn.com/StuartGary. Not only does NordVPN protect your data, but it gives you access to content from right around the world. If you want to watch a science series that's only available in another country, no problem. Just switch your virtual location and unlock it instantly. And of course, the whole thing is risk-free with a 30-day money-back guarantee. So you've got nothing to lose and your online freedom to gain. So protect your digital life, support SpaceTime, and grab our exclusive offer now at nordvpn.com/StuartGary. That's nordvpn.com/StuartGary. And now, it's back to our show. A new study has found that there are less stars being formed near the galactic centre of the Milky Way than the rest of the galaxy, despite the higher stellar density there. The surprising results, reported in the Astrophysical Journal, are based on some of the final observations from NASA's now retired SOFIA Airborne Observatory. The flying telescope, which was mounted inside a converted Boeing 747 airliner, focused on 3 star-forming regions for the study: Sagittarius B1, B2, and Sagittarius C, all of which are located near the very heart of the Milky Way galaxy. The authors found that although the central part of our galaxy does have a much higher density of star-forming material than the rest of the Milky Way, the current rate of stellar formation producing massive stars, larger than say 8 times the mass of our Sun, appears to be unusually low. The authors reached their conclusions by comparing these 3 galactic centre star-forming regions to similar-sized regions further out in the Milky Way, including some closer to our own Sun. And it confirmed that the rate of star formation is below average near the galactic centre. In fact, the study has found that despite the galactic centre's dense clouds of gas and dust, conditions that typically help produce stars with high masses, these star-forming regions actually struggle to form high-mass stars. What's more, these studied regions also appear to lack sufficient material for continued star formation, and that's suggesting that such regions are effectively producing just one generation of stars, unlike typical star-forming regions which produce multiple generations. The study's lead author, James DeBeeza from the Search for Extraterrestrial Intelligence SETI Institute, says these new findings are suggesting that in fact there may be no present-day star formation occurring in the area at all. Beezer says that since presently forming massive stars are brightest at long infrared wavelengths, astronomers were able to obtain high-resolution infrared images of our galaxy's central-most star-forming regions. The data does show massive stars are forming there, but they're forming in really low numbers. The authors suggest that the reason for the slowdown in star formation could be due to the extreme conditions which are found at the galactic centre. See, these regions orbit swiftly around Sagittarius A star, the supermassive black hole at the centre of our galaxy, a massive gravitational well with 4.3 million times the mass of our Sun. And there, they're interacting with older stars, and possibly also with other material that's falling towards the black hole. And these conditions could be inhibiting gas clouds from holding together long enough to form stars in the first place, and even prevent those that do form stars from staying together long enough for continued future star formation. However, Sagittarius B2 appears to be the exception. Although its rate of present massive star formation is unusually low, just like the other galactic centre regions studied, it seems to have maintained its reservoir of dense gas and dust, allowing for a future emergent star cluster to be born. Traditionally, astronomers have viewed giant H2 regions like Sagittarius B1 and Sagittarius C as hosts of massive star clusters still embedded within their nurseries. But these new observations are challenging that assumption. The authors are arguing that these two regions simply may not fit that classical definition at all. Or alternatively, they may well represent a new previously unrecognised category of stellar nursery. By the way, H2 regions are large molecular gas and dust clouds comprising primarily ionised atomic hydrogen. Enshrouded in gas and dust that obscures these star-forming regions from view in all but the longest infrared wavelengths, SOFIA's high-resolution infrared eyes allowed astronomers to identify more than 6 dozen presently forming massive stars within the galactic centre region. However, it turns out these regions formed far fewer stars, and they topped out at a lower stellar mass compared to the galactic average. This is SpaceTime. Still to come, another lunar lander crashes onto the moon's surface, and later in the science report, a new study may finally have solved the mystery of why cats purr. All that and more still to come on SpaceTime. Japan's ice-based lunar lander Resilience has crashed onto the surface of the moon while attempting its landing. The failed touchdown is the latest casualty in an ongoing commercial rush to reach the moon's surface. Engineers declared the mission lost several hours after communications with the spacecraft suddenly cut off, less than 2 minutes before the expected touchdown. Until then, the descent from lunar orbit appeared to be on track. An investigation is now underway to try and determine the exact cause of the failure, but initial analysis suggests a problem with the spacecraft's laser altimeter system appears to have resulted in the lander descending too quickly. It was just 2 years ago that iSpace's first lunar landing attempt, Rashid, also ended in a crash landing. In fact, that's why they named the second lunar landing attempt Resilience. Launched aboard a SpaceX Falcon 9 rocket from the Cape Canaveral Space Force Base in Florida back in January, Resilience shared its ride to orbit with Firefly Aerospace's Blue Ghost. Blue Ghost reached the moon faster and in March became the first privately operated mission to successfully land there. Another private company, Intuitive Machines, arrived at the moon just a few days after Firefly. But it fell over on its side during its landing attempt near the lunar South Pole, forcing mission managers to declare it dead within hours. Resilience was on a far more roundabout journey. It was targeting the Mare Frigoris, or Sea of Cold, located nearer the northern lunar pole, and it only achieved lunar orbit insertion last month. Mission managers thought they were playing it safe. The target landing site was far less treacherous than others, a far flatter terrain with fewer boulders. It was in a long and narrow region full of craters and ancient lava flows, which stretched across the lunar nearside's northern tier. Resilience was designed to beam back images within hours of touchdown and then lower a small 5-kilogram rover named Tenacious onto the moon's surface to undertake a sample mission. Made of carbon fibre reinforced plastic with 4 wheels, Tenacious was equipped with a high-definition camera to scout out the area and a scoop to collect lunar regolith for study. Sadly, all was for naught. This is SpaceTime.
Ready to make a real impact every day? Join the Active Day Home Care team and help clients maintain their independence in the comfort of their own homes. Make a difference in someone's life as you provide essential daily assistance and protect their health and happiness. Earn up to $20 an hour and enjoy additional perks like optional daily pay, 401k, paid time off, ongoing educational training, and more. Join a team that values care, compassion, and your professional growth. Visit activeday.com to apply.
And time now to take a brief look at some of the other stories making news in science this week with a science report. United States authorities have arrested another Chinese scientist working at the University of Michigan for allegedly smuggling biological pathogens into the country. The accused, who's a member of the Chinese Communist Party and worked at Wuhan, was taken into custody at Detroit Metropolitan Airport after arriving from Shanghai. Federal documents claim that she had previously mailed toxic biological samples described by the FBI as involving worms hidden inside books to fellow staff at the university. This is the second recent case involving the suspected transport of unauthorized sensitive scientific material from China to the United States. Last month, 2 other Chinese nationals, one of whom is also a member of the Chinese Communist Party, charged with smuggling a fungus into the United States, which scientists are describing as a dangerous biological pathogen. This fungus is designed to cause disease in wheat, barley, maize and rice. In fact, it can wipe out entire crops, and if it gets into food, can cause vomiting and liver damage. The fungus is described in scientific literature as a potential agro-terrorism weapon which is responsible for billions of dollars in economic losses worldwide each year. As far as this latest case goes, the FBI say authorities found a document on the accused's phone which was titled Plant Pathogen Warfare. Interestingly, everything else on the phone had been wiped. Of course, all these arrests are coming in the wake of the Chinese government's COVID-19 pandemic. The World Health Organization says over 7 million people have now been killed by the COVID-19 coronavirus since it was first detected among workers at China's Wuhan Institute of Virology back in September 2019. However, the Lancet Medical Journal estimates the true death toll is likely to be above 18 million, with some 775 million confirmed cases globally. Scientists have used mRNA technology to expose dormant human immunodeficiency virus hiding inside infected cells. The research, reported in the journal Nature Communications, is considered a crucial step towards eliminating the deadly disease. The study shows that mRNA can be delivered through lipid nanoparticles, the same technology used in COVID-19 vaccines. And from there it can reach HIV-infected cells and force the virus to come out of hiding. That's been a long-standing obstacle in finding a cure. The human immunodeficiency virus HIV attacks the immune system, causing acquired immune deficiency syndrome or AIDS, which allows opportunistic diseases, normally easily combated by the body, to take hold, eventually killing the patient. The World Health Organization says that since it was first identified back in 1981, AIDS has killed over 44 million people globally and infected up to 113 million. HIV is transmitted through body fluids, and there is no cure, although it can be controlled using a combination of complex drug cocktails that need to be taken for the rest of your life. A new study may have finally solved the mystery of why cats purr. Despite humanity's long relationship with domestic house cats, the purr remains somewhat mysterious, and its purpose is still up for debate. So is whether similar vocal vibrations in big cats is also counted as purrs, or if the phenomenon is actually unique to the small members of the cat family. Now, a report in the journal PLOS ONE has analysed the DNA and owner-reported behaviour of some 280 domestic house cats. And the authors were able to identify a gene specifically linked to purring as well as other forms of cat vocalizations. They found that cats with short-type androgen receptor genes were reported to purr more by their owners than those with a long-type gene. Male cats with the short-type gene were also reported to be more vocal towards humans. Androgen receptors mainly regulate testosterone, so the length of the gene is likely influencing testosterone-related behaviours, and that appears to include vocalization. By examining the genes across 11 cat species, the authors found the long-type version of the gene was really only present in domestic house cats. Even their closest living relatives, the fishing cat and the leopard cat, didn't have the longer form of the gene. And that suggests that it probably arose during cat domestication. Previous researchers also found that purebred cats are more likely to have the gene than mixed-breed cats, which often begin their lives as strays. Scientists from the universities of Pisa and Strathclyde claim to have discovered an underground city beneath the pyramid complex at Giza. The authors claim the complex is located under the Pyramid of Khafre, one of the 3 primary pyramids of Giza, alongside the Khufu and Menkaure pyramids. These iconic structures are believed to have been built around 4,500 years ago and are located on the west bank of the Nile in northern Egypt on the outskirts of the capital, Cairo. The authors claim radar images are showing what appear to be massive vertical shafts, spiral staircases, canals resembling pipelines for a water system, and a hidden world of rooms and structures more than 600 metres beneath the surface. They're even suggesting the legendary Hall of Records, a purported library tied to ancient Egyptian law, could lie within this underground complex. The trouble is, the findings are yet to be published in any credible peer-reviewed journal. And Tim Mendham from Australian Skeptics points out reputable archaeologists and Egyptologists appear to be fairly sceptical about the research and are questioning its very credibility.
People have published a paper saying that they found this huge cavity underneath the Khafre pyramid. There's 3 pyramids at Giza, and that they found this huge cavity underneath using satellite radar, and this whole cavity with huge columns and all sorts of things, an enormous thing that goes down hundreds and hundreds of metres below the surface, and that some people are claiming it was used as an energy generator.
Wasn't it just the Queen's tomb? Like the King's tomb was located in the centre of the pyramid up high and the Queen's tomb was underground?
It probably is, but I mean the Queen's tomb not necessarily that deep, I don't think, and not necessarily that big, but it's become a bit of a thing, amongst all the post-Von Daniken people who claim that ancient civilizations had a lot of secret technologies that we don't know about. People are pointing out that actually probably radar from satellites can't reach as low in the ground as they can in the depths of the ocean. But there's no evidence to support it. It's been soundly criticised by Egyptologists and archaeologists the world over, and it looks like it's going to just disappear like another rather silly theory. But it's raised a bit of fun, it's raised a bit of interest, it raised some conspiracies.
You wonder whether it's the Italian archaeologists who carried out the research and published the papers, or whether it's the way the story was then manufactured for the media, probably by the university's press people.
Yeah, probably a bit of both. I mean, the paper does talk about an underground city or a huge space anyway, and universities do like to promote heavily their research output because it's good for their grants applications and their sort of sponsorship from rich people. It gets people coming to the university, and there's a lot of competition between...
No, next thing you'll be talking about cold fusion on the table.
University PR is PR, but I mean, this particular case, it probably won't go very far. I can make a prediction, a psychic prediction, that this particular story is not going to take us very far down the track to super energy systems below pyramids.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.